Before we start this question, okay, let's do some recap, okay, on what you have learned so far. Is that if you have a triangle like this, and if you are looking for this part, this is called the length of projection. Okay, the length of projection, because we are looking for adjacent, it is the modulus of A dot B hat. Okay, and A must always be the hypotenuse, B would be the floor. Okay, and if you want the projection vector, is going to be equals to A dot B hat, okay, and this is the scalar, times of a vector B hat. Okay, so that's a projection vector. And if you are looking for this part, the perpendicular distance from B to AF, that would be the magnitude of A cross B hat. Okay, because A cross B hat is going to give you a vector, so a magnitude of a vector is going to give you the length. Okay, so make sure you know these two very well first. Now, the information has already been given to you. Okay, A is, okay, be careful over here, this will be 1, 3, negative 4, and this will be AB. So first, we always need to find the vector of AB. Okay, the vector of AB is equals to B minus A, and that will be equals to this. So this guy is kind of like your hypotenuse. So make sure you remember that this is my hypotenuse. Okay, you don't have F, so that's why we want to find the exact length of AF, means we are looking for the length of projection. And we know that there is a D vector there that is given as 2, 1, 4. This guy is my the floor, okay, in the case where I use as an analogy in my previous example. So in order to find the length of AF, we know that we are going to look for the length of projection, which is like L, and that would be the modulus of A dot B hat. Okay, so how, I'm just going to apply everything inside. This A is AB, so I cannot write A because A is A. So AB dot D hat. Okay, yeah, that's better. AB is 4, negative 1, 1 dot, now D hat, the formula for D hat is D over magnitude of D. So I can actually just put the whole thing inside, or if you want to do it separately, that would be fine as well. That means this will be 214 over the square root of 2 square plus 1 square plus 4 square. Okay, so don't times in the scalar, pull the scalar out. So that will be 1 over square root 4 square 16, 17 plus 4, and that will be 21 of 4 minus 1, 1 dot 214. Okay, and that will be equals to 1 over square root 21. I will just put in 4 times 2, x times x, plus y times y, plus z times z. Okay, and that would give you my answer. 4 plus 4, 12 minus 1, that will be 11 over square root 21. Okay, units, and that is my length of AF, which is the length of projection, okay, in this case. So the scalar, we can always pull it out, okay, so make sure you know. Alright, so now I can look for part 2, which I want the exact length of BF. I'm going to do this in red, okay, so BF is the opposite side. Opposite side, we think of sine. Sine, we think of cross, okay? So when I want to look for BF, is going to be just equals to, now I'm going to use this cross first, but actually I want to tell you that there's an easier way to do it. Okay, that would be AB, which is the hypotenuse, cross D hat. Okay, and AB cross D hat is going to give you a vector, so you need the magnitude of this. AB, I have 4, negative 1, 1, cross, remember D hat is 2, 1, 4, which I already found, over square root of 21. Okay, so always pull out the, now you need a big magnitude over here. Pull out the 1 over square root 21 first. I will have 4, negative 1, 1, cross 2, 1, 4. Okay, so remember how to do cross. Cover the first row. So 1 over square root 21 is here. You are going to get a vector, but there's a modulus here. Cover the first row, downward cross minus upward cross, so this will be like negative 5. Minus 4 minus 1, okay? Cover the second row, put the negative in the middle first. Downward cross 16, minus upward cross minus 2. Okay, cover the third row. Then downward cross, 4 times 1, 4. plus 2. Okay, so that will be 6. 4 times 1, 4 plus 2, yeah. Okay, then I will have 1 over square root 21, the magnitude of negative 5, negative 14, and 6. Okay, so work it out. 1 over square root 21 multiplied by the Pythagoras theorems of 5 square plus 14 square plus 6 square, and you are going to get your final answer. You can key this into a calculator and get 3SF. I don't think that's a big problem, but if they want it to be in exact form, then the final answer would be square root of 257 over 21 units. Okay, but what I want to tell you is that there's a shorter way to get the perpendicular side. So now I blow up this triangle again. Okay, we already found here from part 1, which is 11 over square root 21. Now, and over here, this guy AB you already have, which is 4 minus 1, 1. If I can find the length of AB, then isn't it easy to find the length of this, because this is just Pythagoras theorem. So the length of AB is just equals to the square root of 4 square plus 1 square plus 1 square. And that will give me square root of 16, 17, 18. Okay, now so for this is just the Pythagoras theorem. So the perpendicular distance is just equals to the square root of hypotenuse square minus the adjacent square. That would be equals to square root of 18 minus 11 over square root 21 square. And you will still get the same answer of 257 over 21. Okay, if they want it in exact form. Okay, so play smart. If I want to find the opposite length and I already have the length of projection, then use Pythagoras theorem. Okay, if you don't have, then you can just use cross. Okay, if there's too much thinking for you and you just want to know, okay, adjacent length I use dot, opposite length I use cross, then that is fine for me as well. Okay. Now for part 3, if the question wants the vector, okay, so let me just pull this out and then do it on another side. Okay, question wants the vector of AF. So AF is the projection vector. If you still do not know that this is the projection vector, then please refer to the previous few videos to make sure you know very well what is what. Projection vector, and that would be A dot B hat, and this is a scalar times of a B hat. Okay, so this is the application, and we already know what is A dot B hat from the first part. Okay, if not, I'm just going to write down in all. So A is AB, that's the hypotenuse, dot D hat, okay, times of, okay, D hat. So this I already have 11 over square root 21 because this is the length of projection. Times D hat, so times of D hat. So what is D hat? Again, D hat would just be D over the magnitude of D. Okay, and that would be 214 over the square root of 2 square plus 1 square plus 4 square. So that would be 214, which is a vector, over square root 21. Okay, yeah, so the final answer would be 11 over 21 times of a vector of 214. That, because this means that this over here, this vector is very long. I don't know how long is it. Okay, in the next chapter when you do lines, you will understand why is this vector D over here. Okay, and I already know that this is 11 over square root 21. If I can cut one of these as D hat, then I know that this is going to be 11 over square root 21 times of D hat. And I just apply in, I can multiply the scalar with each other, the vector don't touch. And this is how I get the projection vector, okay, of AF. Okay, and the last part, if I want BF, then that would be equals to, okay, BA plus AF. All this I already have. BA is negative 4, 1, negative 1, plus AF, that will be 11 over 21 times of 214. Okay, so all you need to do, in this case, no choice, you have to times in the scalar first. Okay, times in the scalar first, then you add together, then you are going to get like 62 over 21, negative 32 over 21, as well as negative 23 over 21, and it will be good if you can take out the 1 over 21. Yeah, 62, 32, and negative 23. Okay, this will be a better way. Okay, so this example shows you how to present, okay, when you need to find the length of projection, the opposite sides, okay, and sometimes you can use Pythagoras theorem and how to multiply in without, okay, using the scalar, okay, and this is how you do a question, okay, when you want to find length of projection and opposite length.